Hey team, welcome to another little mini video. I've been doing this repair cafe lately, which is something I'm really into. It's fun and it's radical and it's a really nice bunch of people. I've really enjoyed buying a few extra fun little tools that I've learnt from other people or I've picked up because I've found that they're useful. I'm really enjoying the dental tools, the little stainless steel dental tools. Really useful for picking things apart. Bit of amateur dentistry as well in the meantime. And I've picked up a few different things. I've got trying to do a bit more soldering because I'm really bad at it and lots of people at the repair cafe are really good at it. So I've got a little fnursy soldering iron just for a little bit of practice every now and then. Sometimes people bring you stuff and it's a bit dirty, and I just thought it would be really good to have a little miniature Hoover. And I got this, which I thought was cool. I've seen them in the past. And I thought, oh, that'll be really useful. Just it's small, I can carry it around, get some coffee grounds out of this bit of a coffee machine or some dust out of that bit of a hi-fi or whatever. And so I got it. Look, it's really cool. It's only 12 quid. Has all the accessories of the full-size Hoover. It's like a little Hoover for mice. It's powered off AA batteries. It's great. It has one flaw. It's shockingly bad at sucking anything up. I wasn't expecting miracles, you know. I know it's a corporate toy, but it's terrible. Let me demonstrate. Here I have a pile of very light sawdust. You'd have thought it had smashed that up from a distance. It can barely lift it when it's right on top of it. And to counter the fact that it's rubbish at sucking stuff up, it blows out the back of it loads of air. So, not being a Hoover engineer, I would have said that if that much air comes out the back, the same amount of air should be coming in through the nose. To a degree of efficiency. I've made a right mess there. I mean, I will clean it up with this now. God, it would be easier with a sake. I'm not doing it. It's ridiculous. So, most people would have thrown it away and never used it again and reminded themselves not to buy silly toys off the internet and expect them to be good. But me, no. So I've got a theory. I've got some improvements planned. It's a two-stage process. But first of all, I thought we'd get some benchmarks. I have here a, what do you call that? An anemometer, measures wind. And I printed this special funnel that goes into the nose there. And so, first of all, we want to get a little test of that to see how much Henry pulls. All right, so funnel on the back of him, no fingers in the way. Oh, come off it. Right, so absolute madness, there's nothing coming in there. This little fan in here is so light. So Henry's sucking power on the anemometer is, in the sawdust test, rubbish is the measurement. And in the more scientific anemometer test, 0. Oh look, here's an experiment. He's blowing a solid 2.4 metres per second out the back there. So why can't we get that through the front? That was with leaking air everywhere. It didn't even have a special exhaust funnel design. This is honestly, I can't remember the name of the company that makes Henry, but Paladone, who make this, you should be ashamed of yourself. This is, yes, a silly toy, but at the same time, what the hell? It does nothing. So let's improve it. The first improvement, I think, since we know we've got tons of air coming out the exhaust and 0 air coming in, we've got to have leaks. It's got to be coming in, I'm guessing, through the side. There's absolutely 0 seal around the edge here. It's messy, this now. So, I want to put a seal around the edge of there. And what I've found, this bit of, what is this stuff called? It's rubber. Neoprene. I think I went for 1/2 mil, because there is no gap. I mean, it is a tight fit. So I just want to basically put a bit of a seal around here. I'm going to draw around this on the back of there. I'm going to cut out a nice thin circle of this stuff with self-adhesive. and I'm going to push it and stick it right into the gap there. Alright, one ring. I'm a little concerned that it's freezing out here, and the self-adhesive glue might not be very adhesive, so I'm just going to warm it up a little bit. You know what I need here? This wasn't a plant. They're just useful for absolutely everything. Tiny dental tool. So that's all new. One thing I might want to fix here is I might need a really, really sharp knife, but I cut it with a pair of scissors and it's not a great circle. And these 3 screws are going to mean this inner part comes out, so I might need to trim the inner part just around the edge of this inner part. Think about sharpening the crap out of this. Maybe I'll do that. Alright, it's not perfect. We'll see if it works in a minute. I haven't really got sharp enough knives in my life at the moment, which is a sad story, isn't it? But let's see if it fits. Oh, it's tight now. You know what it needs? A bit of silicone. There we go. Look at that, easy now. Alright, let's put some batteries in it and let's do a benchmark with a rubber seal around the top. Okay, let's check it out. So, oh my goodness, we've seen a definitive improvement. 1.4 meters a second is our new figure. It's coming and going. Nice new whistle. Now, after stage 1, the real world test here. That's better. Oh, it's got a whistle to it. My goodness. Okay, now, that's working a lot better. Look, I've actually hoovered that up and it wasn't that hard. Most people would say, nice, now I've got a little tool that does a thing that's occasionally useful. But this little Henry's got more in the future for it, alright? That was fairly straightforward. So it's just screwed together, nice and easy to take apart. There we go. Alright, so that's your hat part over there, and here's the workings. Battery pack with a switch and a little fuse. And so then in here we've just got a little impeller that does the sucking and the blowing. But importantly, I noticed, look at this, totally standard, what's this called, 313, 303, something like that, motor. And I thought to myself, maybe this can be improved. So I went on the internet and I discovered this awesome thing. It's a Japanese tuned 313 motor. It may not be 313, what is it? And this is the Sprint dash motor, not the Hyper dash motor or the anything else dash motor. This is the most RPMs I could find in these motors. This is a Tamiya motor. They're actually used for like a little Japanese racing thing that people know about more than I do about. So I'm going to be slotting that in. There was a problem. This runs on a lower voltage than this one. So, first of all, we're only ever going to use NIMH batteries in there, which means we get a lower voltage naturally. And second of all, we've got to change how it works. So I've got this switch, and what we're going to do is we're going to put a new mega switch on it so that we have one way to switch it on, latching, Hoover, normal, and then the other way, non-latching, is going to overvolt the motor for a little turbo boost when we need it to really suck some stuff out of some places, which means that we're going to get rid of all of this button materials, and we don't need a fuse. We're going to be fine. And also, because the new Sprint Dash motor uses a lot of current compared to this motor, we're going to have to upgrade the wiring as well because it's too small. So that is the negative terminal of the battery pack. That's the positive terminal of the battery pack. And then we just have our positive terminal coming down to the circuit board here, going through the fuse and the switch, and then onto the battery. So we're probably going to drill a hole and solder it, one positive terminal coming out this side of the second battery, and keep this terminal coming out of the third battery. Using the switch, I can take about 2.8 volts out of there, and then I can switch it the other way, and I can knock it up to 4 when I just need a bit of extra power. Let's try and carefully desolder this using the new soldering iron. So that little ring holds the ribbon that is used for pulling the batteries out, which is absolutely essential in this particular device. And this was the circuit board that went on top of it, and I actually just desoldered everything. So I could just put this piece of it back, which will stop the ring from coming off. Okay, so the theory is this. 1.2 nominal, so about 1.35 each when they're fully charged. 4 volts out of them all together from the ends. Now my theory is, if I connect one positive to the third battery, there, stay where you're supposed to, and one positive to here, the second battery, when I switch this one onto the motor, it'll run at 2.7 volts, thereabouts. And when I switch that one onto the motor, I get 4 volts, which is good. Here's the batteries, right? That's the positive on the third battery there, where the power is taken currently onto the board. And I need to get onto the positive on the other battery. And I don't know if you can see down there, but there's a link between the two batteries, which is just a piece of wire, solid wire, that runs down there on the inside. My theory is, if I drill a very small hole in here, right where that wire is, I can solder a second wire on there. And that will be our middle wire, our low voltage wire. There. So if I can solder onto that wire that I missed at first, that's my second point of attachment. Now I need some decent quality wire. I don't want to go down to my 12 volt box, which is right down the end of the garden. Have I got any here? Because it's raining a lot. Don't want to go and get the right thing. Just want to use something nearby. What about there on the floor? Oh yeah, that's a good bit of wire. That's what we'll use. A nice bit of wire from 12 volt planet that I've got at some stage, and it's like 17 times the size of the stuff we're using there, so it's definitely enough. I'm not even going to find out if it is. Okay, some time passed. Last night I ran out of time and I didn't realise how late it was, so I had to rush off, but I can't get any solder to stick down there. I managed to unfold this sort of melted bit at the top, which seems to be part of the design, and I realised you can actually slide out the whole metal thing there. So I tried to attach the solder there as well, just because I had a bit more access and a bit more control. No luck. You can kind of see it's burnt probably. I've got a new plan today. These little connectors came with the switch, and so I've taken one of those and I've just flattened it out at the back, and I put a bit of solder on it, and my plan is to just crimp it on like that, and then I'm going to put a little bit of hot glue on there just to keep it nice and mechanically strong. That should be enough in theory, I think. So what I've managed to do there is clamp that round. It's covered in solder, which holds it together, the tag I've added, but it's not actually soldered onto the wire. So let's get the meter and make sure there's some continuity. There is continuity there. But now we've got positive 2.7 volts, positive 4 volts, negative. So I should be able to get back on it and start soldering on some bits of wire. Okay, I've soldered up the switch. 2 positives go through the switch, and whichever way you select on should send a different voltage down this positive cable, and this is the negative. So I put some batteries in it. Let's just see if it's working before we replace the motor. So, it is not working. Bollocks. I melted the switch, I tried to fix it, it went wrong. I decided this soldering was shoddy anyway. I've redone it a bit better. A bit better. My soldering skills they leave a lot to be desired. I want to get better though, so this is better than it was before. A bit neater. Let's give it another go now. It's tricky because of the filter, but that says 2.7. And then if I push the switch the other way, we get 4 volts, but when I let go, it turns off. So we can just use that for turbo overvolting the motor every now and then. I'm going to open up this lovely vintage Tamiya packaging. I'm going to take off these capacitors and put them on the new motor, and I'm going to try and pull this impeller off, and if I can't pull it off, I'll have to measure it up and I'll have to try and 3D print something to go onto this one. So I've soldered the motor in. I've brought these, I think they're capacitors that come across. I should know what they are, but it's something to do with making sure the power stays stable. I had to be very careful to make sure that it turned the right way, because this motor, if you hook it up plus and minus the same as this one was, it turned the other way. And then once I'd soldered it all in, I realised I'd done that wrong, and so I desoldered it and resoldered it. And then after that I realised I did it right the first time and I had to do it again, because I thought, just guessing, impellers should go that way, and I didn't think that through properly. They go that way. But now it turns on, and then for turbo mode, there we go. So that looks good. And that is really exciting because now the soldering's over and I'm really bad at that. So the next thing to do is try and work out how to get the switch in exactly the right spot and drill a hole in this head just to get that on there. Now, I'll be honest, I think it's quieter. It doesn't feel as powerful anymore. I don't feel like as much air's coming out the back. I wonder whether I've made it worse. Let's find out. So, if you remember, 1.4 meters per second was our previous record. All right, here we go. So, okay, so that's not turbo mode, and that equaled the original speed. So I haven't improved it at all with the motor there. Let's try turbo mode. .7. What's that percentage? 0.3, 0.4, something like a 20% improvement on turbo mode. Was it worth it? Let's do a real life test, because currently that was a right faff and I would just do the seal in future. I mean, that's hoovering stuff up, isn't it? That's good. That's really good. It's a grand improvement, although to be honest, the biggest improvement was the seal just around the edge. And then a solid 20% improvement with turbo mode, when required, is no bad thing. One more thing to do. Henry Turbo. Thank you very much for watching. I will see you on the next one.